Well, hello, my college algebra friends. Hope you're having an awesome weekend. Hey, coming back on Monday, we'll be starting a brand new chapter, chapter 6, and a new idea, system of equations. Now, you should have run into this in Algebra 1, Algebra 2 along the way, but I know sometimes our heads get a little dusty, get some cobwebs up there, so let's shake them off a little bit. What is a system of equations? Well, here we see one here. We have two equations, and how many variables do you have? You see we have two variables and two equations. What we've been doing typically is solving one equation with one unknown. But in this case, we have two equations and two unknowns. And the question is, what do I do? What do I do if I'm asked to solve a system of equations where I have two equations, two unknowns? Well, let's define what we're talking about first. A definition for a system of equations. It's a set of equations with the same variables. The same variables. That's important because if we had a z in here, for example, along with x and y, then we'd have three variables, three unknowns, and two equations. You need as many equations as you have variables in order to solve. So a set of equations with the same variables. We have two equations, two unknowns. Have I said that enough yet? All right, so how could I solve this? Now you could sit and stare and work things out and guess and check, and eventually you could come to that, hey, I think x equals 3 and y equals 1. Because you're all smart and you could figure that out. Now, how can we prove that? Well, if we plug these numbers in, we could check this back out again. 2 times 3 minus 1 for y equals 5. Well, is that true? Is 6 minus 1 5? Of course it is. 6 minus 1 is 5, so that works. But it's not enough. We need to check for y also. So we do, or we need to check the other equation. So let's check the other equation. Erase my little mark there. All right, 3 plus 4 times 1 should equal 7. And guess what? 3 plus 4 equals 7. So that checks out. Now, that works for something like this. That's simple to see, but as the equations become more complex, we will want a simpler method, or not a simpler method, but a more complete method, something that we can run through every time that's better than guessing and checking. So what we'll look at first is the substitution method for solving a system of equations. Substitution involves just what you think it would, substituting in one variable for another. Let's take this first system of equations. We have y equals 2x minus 5 and x plus 4y equals 7. Notice that this first equation is already solved for y. What that means is y equals 2x plus 5. We know what y is. So we can substitute it in right here in the second equation. So I can rewrite the second equation, but instead of writing y, I can write what it equals. So I will have x plus 4 times what y equals, which is 2x minus 5, and that will all equal 7. So again, 2x minus 5 from the original equation 1 up here, I've now rewritten for y in equation 2. Why does that help us? Well, look, now we have one equation and one unknown variable. From here, I distribute. So I'll have x plus 8x minus 20 equals 7. I'll combine like terms. 9x equals 27. And I will have x equals 3. Great, so we found 3. But now we need to find y. So in order to find y, we'll need to plug it back in to an equation. Well, our original equation that we had was y equals 2x minus 5. So if we plug in our value for x, y equals 2 times 3 minus 5. So y equals 6 minus 5, and y equals 1. And that is our solution set. X equals 3, y equals 1. Well, we'll express it in the form of a point. So 3, 1. And that's our solution. And the reason we do that is, if we were to graph these equations, that's where they would cross, right there, 3, 1. You know we're going to be checking that out on Desmos real soon. Well, let's look at a little more complex example. What about something like this, where we have square terms? Well, that's no problem. We can still solve this. What we need to do is get one equation in terms of the other equation. The easiest one to do this with is equation 2. And since y is by itself, we'll solve this equation for y. So I'll bump it out here. 3x minus y equals 10. Can I get y by itself? What would that look like? Well, what if I add y to both sides and subtract 10 from both sides? Then I would have 3x minus 10 equals y. And look at that, y is by itself. And just to make things clear, we'll rewrite it with y on the left side. So y equals 3x minus 10. Great, now we have y, we have variable x in terms of y. So we can sub it into our original equation 1. So again, equation 1 is x squared plus y squared equals 100. So let's rewrite that now that we know y. X squared plus y squared will look different now. Y squared is now 3x minus 10 squared. And that will all be equal to 100. So this is where you may not have seen a solution like this before. Previously, when you saw a system of equations, you may not have seen square terms. So this is the next level. All right, let's expand this. So x squared plus, this will become 9x squared minus 60x plus 100 equals 100 when you do that expansion. We'll now combine our like terms. We will subtract 100 from both sides. To do that, we will combine our squared terms. So we will have 10x squared minus 60x equals 0. From here we can, or minus 60 squared, excuse me. From here we can pull out a common, greatest common factor of 10x. We have 10x minus x minus 6 equals 0. And from here we use our zero product property, and 10x equals 0, x minus 6 equals 0, and you can see that that solution we would have x equals 0 or x equals 6. So in this case, we have two separate values for x, which means we should be getting two different values for y. And if you think about it, our squared equation up there is going to be some kind of parabolic. So it will have two different points of contact if we graph this in Desmos or a graphing calculator. All right, so x equals 0, x equals 6. Let's plug that back in to our equations. Well, the equation that we came up with for y is that y equals 3x minus 10 after we rewrote equation 2. So let's sub in for x equals 0. So one point will be y equals 3 times 0 minus 10. So y will equal negative 10. And that point would be written as 0, negative 10. Great. Now our second point will be y equals 3 times 6 minus 10. So y equals 18 minus 10, and y equals 8. So that solution will be 6, comma 8 as a point. So we have two solutions for this, which we should expect because it's a quadratic. All right. You've now seen two examples of solving systems of equations, one that's straight linear and one that has quadratics. So let's we'll look at one more example now to tie it all back together. What would you do in this case? We've seen a really complicated one, we've seen a simpler one. What do you notice here? Well, we don't have one variable in terms of another. We need to get one variable in terms of another. And in this case, y is by itself. So we'll start by isolating y. And we can do that by subtracting 2x from each side. So if we had 2x plus y equals 1, we could subtract 2x from both sides. And we'd have y equals 1 minus 2x. Now that x is in terms of y, we can sub it into equation 2. So I'll rewrite equation 2 as 3x plus 4 times 1 minus 2x. And all that equals 14. So let's expand this. 3x plus 4 minus 8x equals 14. We'll get negative 5x equals 10, and x equals negative 2. All right, now to put that back into our equation for y, we have y equals 1 minus 2x. So y equals 1 minus 2 times negative 2. So y equals 1 plus 4, and y equals 5. All right, so after all of that, we have negative 2, comma 5 as our solution. So that's 3 great examples for you to refer to as you attempt the work for this week. All right, so what did we just do? Let's pull that all together for the substitution method. First thing we did was solve for one variable. What that means is we got an equation so that it looked like y equals something. We got x in terms of y. We put one variable in terms of the other. So we solved for one variable. The second thing we did was substitute. It is a substitution method. We put what we found for y back into the other equation. And finally, we plug in x to find y. And our solution looks like a coordinate. Our solution is x comma y in the end. Now you could do this the other way. You could solve your equation for y in terms of x and find y first and then go back and find x. All right, y'all. Great job. Hope you have an awesome weekend. Go Team USA. Enjoy the end of the Olympics and get out and run around.